Start recording. Okay. Hello, everyone, and welcome to Handmade Hero, the show where we code a complete game live on stream. We have some new stuff today. First things first, Sergio totally solved our Milton problem from yesterday. So we now have a super good, super full functioning Milton. It's really zippy. It's perfect. I'm pretty excited about this, actually. This is the best drawing we've had on Handmade Hero. This feels like really good. I think it's going to be much nicer to work on the blackboard now. So thank you very much to Sergio for fixing that for us. It feels really great now, even on this super old machine. It's pretty much perfect. The other thing we had is someone was suggesting on the pre-stream that we maybe try CodeXL for graphics debugging, because as you know, this graphics card is really old. So stuff like RenderDoc, which we tried before, just don't work. And so they were saying maybe try the old version of CodeXL because it had to run on these old cards. It's a legacy piece of software that was from that time period. So we downloaded a Node version, and we're going to try it. So I'm just going to go ahead and try it. We're going to try on day 3. So day 388 today. So day 387 source code is what's sitting on my drive right now. So I'm going to just go ahead and see. I've never used this piece of software before. I assume this used to be Gremedy's program, right? Like AMD bought like Gremedy or something, or bought the GR debugger from them or whatever, something like that. I don't really remember, but I feel like that's what CodeXL is like was the latest incantation at the time of Gremedy's thing, but I could be really wrong about that. I don't really remember. That's just my hunch. So we've got this debug here, and I'm just going to try doing what it says. So I've got create a new project for debugging, so I'll just say Handmade Hero. It's a local host. It's a desktop application, so I'll go and pick one of those. We've got that on here. Oops, it's not in there. It's in build. So we just want Win32 Handmade. And then our working directory is not build, it's data, I believe. So we can load our stuff. And we don't pass any command line arguments at the moment, so I think that's really all we need. The source files thing, I don't know if they need that or not, if they can get it out of a PDB or what's going on, but it just so happens that all of our code is in this directory. So I'll just give it that in case that helps. I don't know what this is about, really. It looks just like, how do we determine where a frame is or isn't? Swap buffers would be fine for us. We don't have any OpenCL, we're only OpenGL, so that in theory would be fine. I don't know that we really need much in the way of CPU profiling. Right now we're mostly doing debugging, so I could probably turn that off, but since I don't know how to use this tool yet, I'm just going to leave it on defaults on anything that I don't obviously know should be changed. And so all of that looks fine. So I'm just going to say OK, and then I'm going to see what happens if I run this. I assume that just clicking on this local arrow here will do the trick. I don't know if I need to, I was going to say, so there's places to put the logs. I'm going to have it put the logs in our temp directory here, just because why not? And then I guess I can just leave all of this stuff basically the same for now. So I'm going to hit the run button. There's our, there's Handmade Hero running, and then I'm going to just close it and see if it did anything. I don't know if I needed to tell it to start. Maybe I didn't do that. I'm not sure, or maybe that was enough. It's a little bit behind my head here, so I'm just going to put it in here. So let's see. This just looks like basic stuff, like when a context was created and things like this. So I'm guessing that I probably have to do something to tell it how to capture a frame or something. Like maybe I have to push one of these buttons, Hello? What are you, what is this output properties? CodeXL swear function call history, call stack, locals, watch. So it looks like, I mean, one thing I can do here is set a breakpoint on something. I'm not sure that that's really what we want, but you know, let's just try something basic here because we're just trying to get our feet wet. So here we run the program. It's a little weird that we saw anything on the screen before calling swap buffers, but that might have been from the last run of the game. Like maybe that's just junk that was in the buffer or something, or hard to say. But it did what we asked, which is it did break on swap buffers. And so I guess I'm just gonna kind of walk this back here. So here's a complete history of what happened. So it looks like that worked pretty well, which is kind of nice. So this does look, excuse me, like this looks right. I mean, you could imagine us using this to find bugs, right? This is a pretty nice, like, just if we were to do this ourselves, we would have had to write something that logs all of our OpenGL calls, and here is just a thing that will do that for us. So even that is probably worth it, right? And again, now we can even see, like, this is what I was talking about. You can see how if we have to issue a draw call for every triangle because we have to change textures, right? So, although I am a little bit confused as to why it's always saying bind texture to. Oh, right, because that's the white texture. That's for just the cubes, I bet. But shouldn't we be seeing there should be a bunch of times when we bind something else. Probably not on the first frame, though, because we haven't loaded anything yet. We haven't loaded any bitmaps yet. So it probably just skipped those. Can we go again to the next frame? Not great. I'm guessing I don't need to send that, probably because they're not updating this version of the software anymore. So yeah, it's a little iffy, right? But it did run once. So let's try that one more time. Let's see if I can run it twice, or if it's going to crash every time we try to run it twice. So basically, it can't run twice. Let's just hit debug. I don't know how to detach this. Doesn't look like they have a detach. See, I would like to see where we've broken the bug, because, you know, maybe we've got a bug that's, you know, causing the crash that we could fix, and then it wouldn't be a problem. But it's hard to know because it's not going to tell us where we were getting that crash, right? So that's unfortunate. So I don't know. That could be helpful. It might just not be, because it might be too unstable, but it's a little early to tell, right? So let's take a look at the breakpoint window here. I'm going to delete this. Let's say we were running. So it can run multiple frames just fine. And then I were to break. Yeah. So that really just looks like a problem with CodeXL and not us, unfortunately. Right? I mean, not great. So I don't know. Could it help? Maybe. It's just looking a little iffy there, though, is all. I think what probably I should do is at some point I should update this machine. probably just get a new machine. Honestly, the whole machine is so old; it's a decade old at this point, more or less. At least the graphics card is. So I should probably, just update to a new machine. Maybe we can find some company interested in donating a machine for us to run on Handmade Hero. I don't know. Yeah. Anyway, I'm going to go ahead and switch over to working on the code regular. And we do want to, before moving on, we do have the sort of bug report that came in on the pre-stream. It's also on Handmade Network. I'll pull it up now. That folks found, which might help us out. We don't know yet, but it could with what we were playing around with. So I'm going to widen this a little bit. So let's go ahead and take a look at that here. So here we go. So the problem here is that when we do resolve multisample, depth test is disabled. So basically the thing is that the assumption is that the disabled depth test is creating other bugs for us, and that's the problem. So I'll read this whole thing out, and then we can go take a look and see what happened. All right, so Mox says hi, and I believe Mox is MTS Mox, right? I think MTS Mox, you are Mox on the forums, but you're MTS Mox on the chat, right? MTS Mox is here. I think. Anyway, I'll let you guys figure that out, but I believe MTS Mox and Mox are the same person. I believe a major problem with the attempt to do Handmade Resolve is that the depth buffer is disabled with GL disabled GL depth test, which is true because we do switch that off, right? But this also disables the depth rate and therefore messes up all the following peels. Before using the Handmade Resolve, the blit frame buffer would fill the depth buffer, but now this should be done manually. A good way to demonstrate the bug is to only use peel 1 for final stretches, so not split anything. So a better way is this. I found this out while trying to improve the manual Resolve shader. I believe the depth min max range would give good results, but ran into the depth issue while debugging it. After the depth min max worked okay. If I use sample count fraction to set the alpha value of the combined color and a pound to find depth threshold of, and that, remember we tried to set that and it wasn't working, so we kind of knew something was wrong. We couldn't figure out what. This is a good find. Thank you, Mox. After a bit more fidgeting and actually watching the rest of the episode, I saw that you were also using centroid to get better depth per resolved pixel. With the centroid still used, some edges won't get smooth, the connection of a lower block against a higher block. But disabling the centroid gives weird results along other edges, so I tried collecting all the samples without respect for the depth they have and only setting the GL frag depth to the depth max of the tested range by commenting line 31 to disable the range test. I think this emulates the normal resolve as far as selecting colors the best, but still has the upside of controlling the depth buffer output. That combined with disabling the centroid depth test of opens to get the best result. A bit hacky, but seems to give nice results. So I guess what I would say is everything there sounds really good. I totally agree that the GL disabled depth test, I hadn't thought about that, but it is true that basically when GL depth test, the way that they do the depth testing thing is a little weird. So GL disable depth test is really more like saying GL disable the depth pipeline. And if you want depth writes to occur but not depth test, you don't GL disable GL depth test. What you do is you enable GL depth test but set the depth function to effectively not test. So it's really just more of a misnomer, but it's really GL disable GL depth processing in a sense. And so Mox is completely correct here that GL depth func GL always is the right way to disable that if we want to. I don't remember thinking about this. I suspect that really what happened is it just totally slipped my mind, as many OpenGL state things do. It's one of the problems with programming with GPU, especially, is that because you're not stepping through the code yourself, it's really hard to remember what you're not thinking of, right? Because normally when you write code, you wrote all the code in there, so you know what it did, and you're not going to be stupid enough not to write a depth value in somewhere if you thought you were supposed to, right? And you would see it very clearly if you didn't. But with GPU code, that's not the case. There's all this stuff that's configured, and you're just flipping switches, and if you forget to flip one of the switches, well, some whole set of things might be happening or not happening that you just assumed were happening because in your mind that's what you were trying to do, and you never explicitly write the code for it, so you just have to remember which switches you have set and which ones you don't. In this case, I think I just completely skipped my mind entirely. I don't even think I thought about depth writes. I think I was only thinking about depth testing, and I never remembered, like, oh wait, if I turn off depth testing, depth writing will also turn off, and we need to write to the depth buffer. So anyway, if nothing else, even if it doesn't work, thank you very much, Mox, for looking into that. I probably would have just moved on and never really gone back and revisited it. But now we will, and maybe we can find something that works in the end. Because it would be nice. It would be nice to know that if there was something here that we could work with. So let's take a look at where we left this, because we were kind of messing around with it, and I don't really remember exactly what we were doing at the time. So first of all, this depth threshold should be much too high, probably, although we probably want to look at setting this in a different way. Because remember, the depth range is nonlinear, so probably what we want to do, we might want to try to come up with a way of analyzing our depth separations in a way that's not going to vary tremendously as we progress outward from the camera. Because things that are small changes close to the camera and things that are small changes far from the camera could have different meaning in terms of whether we think they're close enough to warrant peeling or not peeling and stuff like that. So we don't really know the behavior of that, but we might want to look into that, or at least we want to mark it so that if somewhere far in the future people are looking at this code and trying to improve it, they can get a leg up on the fact that that was something that never really got investigated, that sort of thing. Okay. So in theory, this looks pretty good. There's some stuff that I would like to do to it, certainly, but it looks like it's still doing roughly what it should be doing, which is combining the colors and then setting the depth value. It sounded to me like MTS Mox was suggesting that in playing around with it, he found it was better to just actually sum all the colors together. So you don't want to only sum the ones in the depth range. That's what it sort of sounded like he was saying, is what he found for the best results. So we're going to start by leaving this the way it is, but then we'll come back here and try taking MTS Mox's advice to just see whether returning that to a general sum for the color side of things and only using the picking range to pick the depth is actually an improvement visual quality-wise, because it might be. So, okay. So let's take a look here. The reason that I was assuming that wouldn't be the case, because I feel like that would over-contribute things that were underneath, because they'll get contributed on both depth peels, but, it's hard to say, right? Multisampling's a bit of a hack with depth peeling, right, when we're putting them together like this, so it's not unusual to expect that hacky versions of the resolve might also be better, because we're kind of doing something a little hacky in the first place, right? All right, so let's take a look at that resolve code. That's the compile, which is not what I want. None of this is what I want. Where is my actual resolve? There it is. So here's resolve multisample. You can see the disabled depth test here and the re-enabling the depth test here. And what we're basically saying now is that, well, we want the depth test on all the time because it really means depth pipeline. What we don't want to do is we don't want to test against the depth buffer because we just want to write to it. And so we could clear it here or something like that potentially, but that's just wasting time. Since we know we're going to write to every pixel, we just want to say don't test it, right? And so if we just set our GL depth func here, which I believe we were setting here, you can see it to GL less than or equal to. What we can do is just say, oh, let's just set it to GL always, so it never does an actual test against it. And then when we're done, we'll set it back to less than or equal to. So this is effectively turning off depth testing, but it's going to leave depth writes on, right? Because remember, depth mask controls depth writes, and that's set to true, and we're not touching it here. So that was just a dumb thing on my part. Again, I was kind of thinking, oh, I'll just turn off depth testing, but that's not what I was actually doing. I was actually turning off the whole depth pipeline, which I didn't actually want, right? So I believe that was all that MTS-Mox was talking about in the initial set. I'll just verify here that I'm doing similar thing. So that's the same, GL depth func always, less than equal. So that's exactly the same. That's all he's got in the code snippet. So I'm assuming, right? I'm just assuming that is exactly what he tried, and he was saying that was reasonable. So then here's his shader, which let's leave this. Let's leave this alone for a second, so that we could run what we have before mussing with the resolve shader, which we may have to now do. Because remember, we were just trying to play around with it. We never really got anywhere, probably because our depth writes are just completely wrong. I'm going to load Visual Studio, or try to, and that's going to take a good long while. Probably because now we installed the stupid CodeXL Visual Studio extension, which is probably now ruining my life. Yep, there it is. So here that is. Hopefully that doesn't... Does that do that every time? No, that's not too bad. Is there like an auto update feature? Because if there is, I need to turn that off right away. Is there like a extensions add-in manager? Nope. What is CodeXL if it's not an add-in? Extensions and updates? So yeah, enable loading of Perseus. Meow, meow, meow. All right, I don't know. I'm just going to assume that I don't care about this. So we'll just pretend this is fine. I don't know if it's fine or not, but we'll pretend that it's fine. So the first thing I'll say is that that is actually looking much better, right? Because, or wait, we don't, oh, you know what? We don't have the multisample hint on yet. I was going to say we got rid of those things, but it's not on yet, is it? Yeah. I declared victory too early. All right, so let's go turn on the multi-sampling by default. I'm going to clear this guy out here. God, CodeXL. CodeXL! Why did I install that extension? Why did I do it? You know, why did I do it? How do I disable? Disable. Disable. Stop. Bad. No. Incorrect. Should I uninstall it? Can I not just say no? Bad dog. Bad dog. No. Let me see if I can get rid of some of this crap. So that's back to normal. So maybe we're okay there. All right. So I'm going to go into Win32 Handmade. I'm going to try a couple things here. I'm going to just do a couple things to put us into a position to better explore this resolve and just see what we can do here. So the first thing I'm going to do is I'm going to switch to half res, right? So I'm going to switch to this mode, which is 960 by 540. I'm going to turn on the multi-sampling hint by default. And I think is the pixelation hint, I'm just going to look to see where the pixelation hint gets done here. OpenGL frame buffer filtered. On the resolve flags. So I think, don't quote me on this, but I think if I set this to true, I should get 1-to-1 pixels now, I hope. I'm not 100% certain of that, but that was my hope. So I think, now I can actually look and see if I take a look at the print screen of this, I think I can see 1-to-1. Well, it's not 1-to-1, it's 1-to-2, right? Pixels. So I just want to see if that's true. 1, 2, 3, 4, yeah. So this is good. So now I'm in a mode where we can run at full speed, right? Because this graphics card does not like running with multisample at 1920 by 1080. We know that. So I can run it in half res, but I can still see every pixel is now 4 pixels. So I don't introduce any other blurring, which is what I don't want, right? I don't want to introduce linear smear there, which would make it harder for us to debug on the 2x upsample, which is what it would normally do. All right. So if I come through here and run this, right, like now, we pretty much, to be honest, a lot of this is actually looking okay, but it's clear that our resolves, like, the edges are still crispy in some places, although not in others, which is a little bit odd. But we also get these lines down the middle, so we're still having that problem. However, all our artifacts from the peeling are gone, at least most of them are. Maybe there's one like right there. So that's actually a big improvement. So again, thank you very much to MTSMux for giving us the opportunity to work on this again by finding that bug. Bugs like that are real hard to find without a debugger, without an OpenGL debugger, obviously. You got to really look for them. I probably should have had some mode where we draw all of our depth buffers, because then we would have seen that it was wrong. That's the only thing I could think of that would have caught that bug, other than just, straight up inspection of the code more meticulously and hope that you think of it. So now all we really have to do, assuming that that is working properly now, is see if there's something we could do with our depth sampling here. And again, MTSMux is saying maybe just use all the samples, just use them directly, and don't worry so much about the depth min. So if I were to do that, if I basically was to just get rid of the test there, that would give us this. And, some of it looks pretty good. Some of it doesn't, right? It's pretty hard to tell exactly why. I can't say I have a lot of theories. So if we take a look at the difference between multisampling and not multisampling, there's crispy edges everywhere in the non-multisampling version. If I turn multisampling on, the crispy edges go away like here, but they don't go away at places where the cubes intersect. Not really intersect, but abut directly, right? So they are, for all intents and purposes, intersecting. And so the question is, why is that happening, right? And, is there something we can do about it? It does look, I would say at this point, it does look just generally better with multisampling on, which is more than we could have ever said before. So I think thanks to Mox's careful look at the resolve shader, we are in a better place than we were. We're maybe not all the way home because it would be nice to clean up those edges, but despite not being all the way home, I do feel like we've made a visual improvement. So I do feel like you'd rather play the game in this mode than in the other mode so far. Like maybe there's some artifacts we haven't seen yet, but it does kind of look like most of the time what artifacts there are at least no more objectionable, right? So now one question would be, well, what if we go start playing with this shader a little bit more? Maybe there's something we can do that improves it even further, right? That's going to be an even better way to have it run. And so, most of what we can do here, I guess, it just depends on the way that we're picking that depth range, right? And it looks like I've sort of I removed the operable part of it that was previously picking the range. So this is just taking the minimum now. So if I was to go back to doing something more complicated where we actually did pick a range, I wonder if that might be a better place to start. And I suppose I should defer to MTS Mox on this. I assume, yeah. So it looks like he also, and I think that's what I remember him saying, he went back to the depth range version of the shader. Remember, this is how we were doing it previously before we started playing with it some more. So let's go ahead and try that out. So this is basically restoring the way it used to work before when I tried this and it didn't work. But as far as we know, that was really mostly just because we were messing up the depth buffer rights. So let's start back with this and see what happens. And then there's some other stuff we can probably do there to improve things further. So looking at this, I would say it doesn't really look appreciably better than the other version. In fact, if anything, I think it looks a little bit worse than just picking the minimum. You can see some artifacting going on up here that I don't remember having much problems with in the previous version. You can see right in there, you get kind of a nasty problem with artifacting there. And that makes some sense, like that's probably in places where we're just picking depth values poorly. From this tree, at the edge of this tree, to where it sort of intersects where this tree is being picked or something like that, we're probably just doing something a little bit stupid in that case. So I don't know exactly what we want to do here. But it does seem like picking the min is a little bit better in this case. At least as far as I can tell, that seemed like a more sane result, right? So I would say mostly just looking at the game in that mode, you're not seeing those artifacts pop up, I feel like. I'm still seeing, there's still some definite artifacts in, right? You can see as we start to peel away, you still get artifacts on the resolve with those places where the primitives abut. And it does, it makes sense as to why that's the case. certainly. So I'd have to think. I'd have to think of what else I might want to try here. So I guess what I would say is, going back to first principles on this, the thing that's so frustrating about it is we don't even need multisampling for any reason, right? There's nothing actually happening here that we care about multisampling for. The only thing we're trying to do is smooth the edges of our cubes, because our cubes are geometric primitives, not sprites, and therefore they have hard edges. Now, multisampling is intended for this purpose, certainly. Like, the goal of multisampling is very specifically to smooth the edges of geometric primitives. That's what it does. No question about that. But we don't actually want it to be doing all the work it's doing. It's actually creating too much work for us. All we really want it to do is to write proportionally into the pixel it would have filled based on its coverage of that pixel. That's all we actually wanted, right? We don't want to record multisample. We want it to produce one depth value per pixel, and then we want it to, if it touched that pixel, write in a alpha blended color value that does not actually alpha blend. It just writes in the alpha raw. And I just don't know any way to do it. And it's a little bit frustrating because it's so simple in concept, but it's just, I don't know any way to convince the GPU to actually do it. And we end up in this situation where we're bending over backwards to try to produce this other result. I mean, I really feel like we should be able to reconstruct that basically, though, right? So, inside this loop, what we should be able to do is find the depth bin, and we should be able to do this operation, right? That should have worked. And I really just don't know why it doesn't. And I feel like I need to maybe think that through a little more clearly, because I really feel like that should work. I feel like that should generally produce the results that I wanted, right? And I don't quite get why it doesn't. And I think it's a little bit subtle, probably, why it doesn't. Would be my guess. I'm kind of curious, what happens if we turn off sRGB? Just curious. So it's definitely closer to right. And sRGB is always on in this case, right? Because we turned off the, yeah. So I'm going to draw this out on the whiteboard just so we all know what we're talking about and so I can just check my assumptions, basically. So let's talk about what I would ideally like to have happen, but that is not happening right now. So we have primitives that are like these cubes, right? And what happens is along the edges of the cubes, there's a, obviously a change in what's happening along that geometric edge, right? So if we were to take one of these triangles here, like let's say that this was broken up like that, if we were to take one of those triangles that we're looking at, there are pixels right along the edge of the triangle. For any given one of those pixels, here's what I would like to see happen, right? I would like to see it take the percentage of the pixel that is covered by that edge, and I'd like it to turn that into a percent coverage value. So I don't know, maybe that's 50% or something, right? So that would be a 0.5. And then what I'd like to see it do is produce the color value, which is whatever the color value would have been on this pixel. I don't care, do the centroid. I don't really even care at all where you sample it, but sample the color value and then multiply the color value by this alpha to give the pre-multiplied alpha result, right? I mean, that's fundamentally what I want to have happen. All right, let's keep going here. So fundamentally, that's what I want to have happen. And so I want to produce a value in the buffer, I believe, and we can go double check this, but I want to produce a value in the buffer that is effectively whatever this color would be if this is C. I want to do 0.5 C in the RGB channel and 0.5 in the alpha channel. So I want a pre-multiplied result here for that pixel. And I want that stored in the peel, right? And that's it. And then I want its depth value, whatever its depth value was, stored in the peel there. Okay? So that's what I want. Now, that should be approximated by what I'm doing in this shader, which is to say that we've got 8 samples in here, right? And if what I do is I sum up the samples that appear to come from this primitive, which have the same z value, so let's say, in this case it's the same thing, I sum up these z values, I sum up the color values that match the z, which are these ones don't. I sum those together and I should get effectively the same answer, right? I should get that I end up with 0.5, and it won't be as exact as it would have been because we only have 8 samples, so it's going to be more granular, but it's basically the same thing. I would get 0.5 times the color with 0.5 in the alpha channel. Now I know I'm going to get 0.5 in the alpha channel because I'm doing in sample count times the combined color. So however many of those we added up, their alpha value is presumably 1, but then I divide by the total number. So if I only had 4 of them and I divide by 8, I'll get that 0.5. But now the question is, do I end up with 0.5C in the alpha channel? Well, I do end up with 0.5 here, but the problem is thinking about this, where does the sRGB factor come into play? And to answer that question, I feel like I have to look at how we're doing our peel compositing, because I don't really remember. But if you take a look at here, how we're doing it, we square the RGB as it comes in, right? So in theory, we want to do the alpha multiply before doing the sRGB, right? Because if I did it after, then this square would mess it up, right? This square undoes this square root and puts me back into the space where I expect to be. So I'm pretty sure that that is the correct place to do it. Now, when we come through here, peel 3 obviously was going to be handled, especially it isn't now. But we don't care so much about that because we're talking mainly about peels 1 and 2. I'm sorry, 0 or 1 and maybe 2, but probably not. So then we take peel 0 RGB, we assume that that's the correct thing to sum, and then we multiply in whatever the underlying layer is composited to, using the inverse of whatever the peel alpha is. And that seems like the correct compositing operation. I don't really see what's wrong with that at the moment. But something must be. And I'm guessing that what must be happening is what... Well, to be honest, I don't really know. I really just don't know what's happening. I don't understand why I wouldn't sum out to the same value. Because especially when you consider the case of the two triangles touching, you know that like these 4 over here went to one triangle, like this is triangle A, and these went to triangle B along this line, right? Or something like this. They both had the same color value, right? I mean, there's almost no difference between the color values on either side of this triangle. There isn't really even a gradient in play there. You know, maybe you look at this one like there's a gradient there, maybe something's wrong with this, how the color, but this is the same color, right? So all the samples are the same color in both of these cases, so they should sum up to the same thing. So it suggests to me that there is an error here that I just don't understand. And I feel like we need to understand it in order to really say this is or isn't working, because something's wrong there. And the fact that I can't tell what it is bad, right? It means that there could be yet another bug like the one MTS Mox found, that, you know, we may not get lucky. Sometimes you get lucky, someone finds the bug for you. We may not get lucky. So we're the only people who really have to be responsible for finding if there's bugs in here, because, you know, we can't necessarily guarantee that anyone else is going to look at it after and find it. So, yeah, looking at this code, you know, we're fetching the depth the same way both times, so presumably there isn't an issue there. And, you know, we're summing up the color in squared space, which is where we think we should be doing it. And I don't see any problem with that. So, you know, it seems like that's pretty basic. And we're checking for equals to the depth min, which is the value that we're setting the frag depth to, right? Yeah, so here's the frag depth min. That's what we're setting it to. And so the next peel will include all samples that are below that, right? I mean, that's what's going to happen. I suppose maybe, is it possible that the samples are not predictable? Like, if the multi-sampling sample locations were different between the two passes, I suppose that could lead to the problem. Because again, we know that we're just a little bit, we know that we're very granular, right? Because we only have 8 shades of alpha to play with multi-sampling, right? We only have between 0 and 8 are the number of samples that can be covered. So we only have the steps between there, 1, 2, 3, 4, 5, 6, 7, and 8. So really, between 0 and 1, we're only dealing with 7 possible shades in between, which isn't a lot, obviously. So it could be something like that, and I mean, if it was, I guess there wouldn't be a lot of ways for us to test other than if there's some way we can tell the card to always use the same sample positions just as a test. And I don't really know if we can or not, but that would be one way to do it. Yeah, I really can't say I have a good idea about that. I do not know what the actual problem is there. I mean, blending is disabled, so we're not accidentally like double blending or anything like that, at least as far as I know. And so, I really wish I could say that I could think of something else that could be happening there other than different sample positions, but I can't think of much. I mean, I guess there's the precision of the accumulator. Since we're dividing by the sample count every time, I guess maybe I could try to make sure the precision isn't a problem, but I don't really think that could be the case. It doesn't seem likely. But, we could put inf sample count at the top and then add in inf sample count times the color every time. But that, that, if anything, could be less accurate. Oops. So yeah, and it looks basically the same, which is what you would expect. Well, anyone have any ideas? I'm curious to know about where that difference comes from, because I would think that it would be equivalent, especially between those two tiles. And I can't really think of why it's having a difference there, unless there's something about the sampling we don't know, or with it we don't understand. So here's a question, actually, now that I think about it. So do we necessarily know exactly how many samples there are in the pixel? Is the max multi-sampling value, we always have set it to that, right? Like there's no possibility that we have an off by 1 error here where the number of samples that can be summed is actually lower. I mean, if we do sample index 0 to 7, which is what we're doing here, then that's 8 individual things that are added together. So we would want to multiply by 1 over 8, I would think. So it's not some case where like one of these samples doesn't actually exist or something. Like we're querying it and it's not actually there. Or there's one additional sample we're not accounting for or something. But I am not sure. Yeah, I'm not sure. So I'm going to double check the depth peel code. So what we do in the depth peel code is we fetch from we do the TextL fetch. So so here is a question. Do we know that the frame buffer's recording of z values couldn't be involved in this case as well? Like we're using depth component 24 here, which is not the same as a floating point value, right? It's very specifically not. And so I wonder a little bit, like what if we just said, let's make this be something we can set. And, oops, it's the wrong place. And so let's go here and set that to 32F. Because now it's the exact same kind of value. So whatever we actually compute in the shader is what gets stored directly in the frame buffer, and there's no quantization error, right? Nope. Because I was just curious, like when you're dealing with something that's like depth peeling is kind of exact in that sense, and it's like, well, I don't know if maybe we're getting something weird happening there where it's like, oops, you quantize the value, which makes it compare wrong. Instead of comparing less than, it compares greater than or something because you just flipped on either side of it when you were right on the boundary, like you would be when two triangles abut each other like that. So I feel like, when you're in a game of inches like that, you probably want to make sure that you're not, that quantization artifacts are not sneaking up on you there. But that doesn't look like that had anything to do with it. So You know, let me hear me out for a second on this, because, you know, just talk about this for a second. I want to pick out an artifact on the screen here and just talk about it. And I think this is probably the best place to look at it. Well, yeah, maybe not. Maybe this is. Yeah, maybe this is. So, okay. This is a clue, an important clue, I would say. So let's take a look at the hero here. If you take a look at what's happening to him, what I think you'll find, unless I'm very much mistaken, is that we're seeing through the split in his graphics, right? So where the two triangles meet here, it's not a question of an incorrect summation, it's a question of actually peeling it away. So at the boundary, for some reason when we're doing the multisample, rather than the next depth peel actually being whatever the abutting triangle was, it actually looks like it's picking the next thing down, which is kind of what we want if these were summing correctly, but is not actually right by what I think the pipeline should be doing. So it suggests that there's something happening. It suggests that something weird is happening with the depth peel, where it's actually being more forgiving with the depth peel than it should be. And I do not know how that's happening. Because you can see here what it's doing is it's saying whatever the fragment Z is that I was going to write here, if it's less than or equal to the clip depth, then I'm not going to write it. Right? But what we should have seen is that anyone who wouldn't have passed this test should have gotten swept up in this equal statement. Because if you were equal to it, you would be included in the summation. So how is it that something is failing this test, but succeeding this one? Or I should say, also failing this one, meaning it's not hitting the discard, right? Because if it was equal to, if it was less than, it should have been in a previous peel, one before even the one we're checking against. So in 2 peels back, right? So if it's saying that it's not in this, that it's actually at the clip depth or was before the clip depth, then how could it possibly not be in hitting this on a previous depth peel? How is that possible? That's the part that's a bit of a mystery, right? Like, it doesn't seem like that should really be possible to have that happen. You know? I'm not seeing it. Because there needs to be some explanation for why that's happening, even if we don't really care about it from a perspective of, you know, even if we don't think we can really get the improvement that we want, we should be able to fix at least that, or have an understanding, come to an understanding of why it would occur. And I can't think of anything. Oh, I can't think of any reason why that would occur. Because we know we're writing that into the depth buffer. Yeah, and I don't see it. So, blending remains off the entire time, right? Yeah, so I really do not know what the deal is there. I guess I don't know, for GL multisample being enabled, we don't ever have to turn that off, do we? Like, presumably that just turns on or off based on whether you're writing to a multisampled surface, and I'm assuming that you don't really have to enable it or disable it in any more specific way than just to turn it on, and then you'd only turn it off if for some reason you didn't want to write multisampled, right? I wonder if there's anything. I'm going to take a look at core arb. This is me just kind of daydreaming now because I don't have any particularly good idea. I want to take a look at coverage here. So I would like to know what sample coverage value is. Multisampling samples a pixel multiple times with various location-dependent subpixel locations to generate anti-aliasing effects. Multisampling transparently anti-aliasing points if it is enabled. Value is used to construct a temporary mask used in determining which samples will be used in resolving the final fragment color. This mask is bitwise ANDed with the coverage mask generated from the multisampling computation. If the invert flag is set, the temporary mask is inverted, and then the bitwise is computed. If an implementation does not have any multisample available or the rasterization occurs with only a single sample, computing a pixel's final RGB color, provided an implementation supports multisample buffers and multisamples. The final color generated by combining several samples per pixel. Each sample contains color potential, and these numbers to be formed on each sample. Here's a question, though. The question is, could you do that and just give me the value back? This is really what I want to know. I love all these crazy pages that are like basically just the docs from the OpenGL thing moved up. OpenGL 4.5 spec. Let's take a look at the latest spec. If that is the latest spec, I don't even know if it is anymore. But sample coverage. Coverage. All right, the RGB values of the rasterized fragment are left unaffected, but the A value is multiplied by a floating point value in the range 0 to 1 that describes the fragment screen pixel coverage. Wait, this is what I wanted. How do we turn this on? Rasterization is a process by which a primitive is converted to a two-dimensional image, blah, blah, blah. Rasterizing a primitive begins by determining which square is into a gridded window. Yeah, that's fine. A grid square. Associated data. Fragment shape is called a fragment. Yeah, fragments need not be square. Okay. After I was asked for early fragment test, so many fragments. Right. We don't care about any of that. So grid squares need not actually be square in the GL. Fine. Several factors of primitives regarding before. Position points by given rasterization only produces fragments corresponding to pixels in the frame buffer. Fragments which would be produced by application of any improvement of restoration rules primarily allowed. So the failure are not produced, where are they processed? Primitives, right, by enable rasterizer. Primitives can be optionally discarded before rasterizer by calling enable and disable with rasterizer discard. Primitives are discarded immediately before the rasterization stage. Okay, that's fine. We don't need that. Consider primitive P as long as P, yeah, okay, whatever. Anti-aliasing. The RGB value is rasterizer fragment affected, but the A value. See, what are you even talking about when you say anti-aliasing? Like, hello specification, tell me something about when that would occur. Like, this is what we wanted, but I was not able to get this to happen. The per fragment stage of the GL can be set up to use the A value to blend the incoming fragment with the corresponding pixel. All right, I get that. We don't care about that. We just want to write the actual value. The details of how anti-aliasing fragment coverage computer difficult to specify in general. The reason is that high quality stealing may take into account perceptual issues as well as characters to monitor. Okay. Skills might be addressed in the scope of the document. Further, the coverage value computed for a fragment of some random of the primitive's relationship to a number of grid squares neighboring the one corresponding to the fragment. And as right, no consideration. Okay. We all given GL. Okay, fine. We chose to specify the behavior of exact anti-aliasing in the prototypical case that each display is a perfect square of uniform density. The square is called a fragment square and has the lower left corner xy, upper corner x plus 1, y plus 1. Recognize that the symbol box filter map is the most favorable results, but for a simple, well-defined model, a GL implementation may use other methods. Okay, fine. In some cases, varying degrees of anti-aliasing quality may be retained by providing GL hints, but allowing user to make up, I think, for speed up. But how do you get it to actually turn on? That is the question. Like, this is all we actually want. We want this section of the spec to occur. And then we could get rid of multi-sample buffers entirely, right? That's all this is all we actually wanted. But we were not able to get that to occur. Yeah. Anyway. I don't think we care about any of this. Is there anything about anti-aliasing in the polygon section? Polygon anti-aliasing will rasterize a polygon by producing a fragment wherever the interior of the polygon intersects the fragment square. A coverage value is computed at each such fragment, and this value is saved to be applied as described in section 17.1. An associated datum is assigned to a fragment by integrating the datum's value over the yeah. So why could we not get that to happen? We want that. We wanted to at least try that. The interpretation of polygons for rasterization is controlled using polygon mode, blah, 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 which we don't care about. We don't care about polygon offset either. Regardless of whether polygon anti-aliasing polygon smooth is enabled or disabled. Did we ever try turning that on? Curious. Yeah, is that... Did we do that? Maybe we didn't do that? What happens... Let's just... I'm just curious. So let's say we don't have multisampling on. right? So this is the non-multisampled game running in low resolution at the moment, because why bother setting it back up? We don't really care. We just want to know whether we can smooth some things, right? Okay, so now let's go in here and say, okay, GL enable GL polygon smooth. Start with that first. What does that do? I don't see any polygon smoothing at all happening there, so that doesn't seem to do anything, right? I guess I could disable multisample as well, just to make sure, because we're not using it at the moment, so it wouldn't matter. I still see it. I see no smoothing. GL hint. I think that person had it there, right? Yeah. Just in case. GL parameter target has an invalid enum. Is that not allowed? There it is. Still see no smoothing. Now, we're going to totally wreck our rendering here in a second, unfortunately, but I'm going to go ahead and do a GL enable GL blend, right? And do we ever enable blending again? No. So in theory, if I enable blending, which should allow it to draw, and then I set the blend func to 1, 0, I'm still not getting any smoothing. So it's not, because it should just be writing that alpha value in. Although I guess we would it doesn't know to pre-multiply the alpha value, so let's just to see again. I just want to know whether you can ever coax this into producing a primitive at all. It really doesn't seem like it. Like I should see something, right? I mean, maybe not, but I mean, here's an example of something that's just against the background. I should see some color variation or something there, but I'm not seeing anything, right? So I don't know. How do you get... Oh, whoops. All right. Yeah, I mean, unless I'm missing something, it does not look like, even though that's specifically stated in the specification, I don't see it turning on at all. But it's supposed to, right? I mean, it's like that whole section in the spec specifically says that you're supposed to be able to turn on some kind of anti-aliasing, right? So I guess what I don't understand is why that's not... why that doesn't seem to ever produce it, because I really would have liked to be able to get that, but I can't seem to get so. The first test in the location of the frame buffer is when a system and draw buffer, right? Yeah. Scissor test should be fine. So I don't see, yeah, I literally see no reason why we shouldn't be getting polygon smoothing there, right? So it looks like basically that part of the spec is just ignored, maybe. And it's just like, hey, yeah, sorry about that. We just don't care about that idea. All right. Well, it would have been nice. All right, so yeah, I mean, honestly, I don't know. I don't have a lot of ideas as to why we're not getting an even summation on there, because we're clearly getting something where it's knocking out a pixel which I feel like should have belonged to the subsequent depth peel, but doesn't appear to. And maybe the problem there is just the summation from depth peel to depth peel is incorrect, because I suppose that would do it. Like if it was underweighting them in some way, that I suppose could be part of the problem. What I feel like maybe if there was some kind of a problem with the alpha that was being picked up at that pixel, like the alpha value was not correct. So it was getting underweighted. Like I don't understand exactly how that would be possible, but it's just I'm saying that it's something that would cause it. So for example, in here where we're doing this summation, we're sort of assuming that the alpha value is 1 for all of the samples along that border, and there's just a fraction of the samples. But I don't know, like, is there something that's creating non-1 alpha values there? I don't know. And, you could imagine us specifying this more stringently by doing something like this. Combine color RGB, combine color A plus equals 1, right? So if we just assume that well, I mean, you know what? Probably that's probably dumb. Right, just so like we don't care what we fetch out of the buffer. Even if the alpha value appears to be something, we're going to set it to 1 anyway, right? So, looking at that, so I mean, that to me, again, like, I just do not understand what I'm seeing then. Because now, I mean, you can ignore all the black stuff here. That's what we would expect, right? We're taking pixels that should have an alpha value, and we're treating them like they are solid. But I'm talking about for these in-between pieces here. Like, now we know that that's not happening, right? The alpha value is full on, and it's still getting that same error. So the summation here across the boundary is just plain broken, but I have no idea why it's broken. I don't understand how we're not getting 2 even sides of the sample count to sum up properly. It doesn't make a whole lot of sense to me. No. All right, good. Whew. That was bugging me. I think I get it now. All right, so let's turn this into something where we're looking at the actual depth layers. Here's the peels. So here's our pixel, right? and we're doing this, these fall on the top depth peel, these don't. So they get moved down to this depth peel is what's going to happen, right? These still happen on here, but they're already taken care of, so they're rejected, right? And then there's something down here. Well, what's going to end up happening is the alpha value here is 0.5, and the alpha value here is 0.5, but this is on top blending. So what's going to happen is this 0.5 is going to add with this 0.5, right? And rather than producing 1 and not summing this, it's going to do an on top, right? It's going to turn this into a 0.25, and it's going to add 0.25 of this, which is wrong. And I don't see a lot of ways around that. I mean, I think this is basically why people use multisampling in the regular situation, is specifically because you don't know what the alpha value is actually trying to tell you. Effectively, what it means is that when you have multisampling, you need to track how many actual samples there were in the depth range, and then use the... So here's a question. If we just take the whole thing, what happens if we just take the whole thing? If I just say, give me the maximum, give me the highest, give me the furthest back, right? Furthest back thing, sum all the colors. What happens then? What does that look like? I'm curious to know. So we get some artifacts specifically where the tree boundaries overlap each other. But now we don't have that problem, right, of the... Yeah, we don't have the problem where we get those cross purposes. So we're only talking about the fringes once we switch that on. And then we're good to go pretty much everywhere else, right? So in that situation, we're just back to the old problem that we had before where, and presumably this is what's happening in the regular resolve too, right? Because this is the problem we had when we just used the default resolve. And that problem is just that when you get out to the fringe edge, you are going to produce an alpha value that's too low, and you're blocking the other pieces from showing through. But at the end of the day, that's really more of a problem with the fact that we don't clip out the alpha when it gets down to that level. Because if there was still something to be contributed here, then the peeling, like we're really just talking about the fact that these peels are overlapping directly in Z, and so we end up underweighting one of the other values. So I'm interested to know what would happen if we put in some sort of an alpha threshold here and just play with that a little bit. I'm curious to know. Right? So that sort of wide apron artifacting is more or less controllable by the alpha threshold. What happens when we come down through? Still get some sparklies, though. It's pretty interesting. That's pretty interesting. So I also wonder a little bit, I want to try one thing here. So for intersecting, I don't know that there's much we can do about intersecting cubes, because in that case, the multisampling is not going to help, right? So for intersecting cubes, I would actually need to do something where we actually record the values there, because the multisampling isn't going to help, I don't think. Trying to think if there's a reason, if multisampling, if we were just doing regular multisampling, would it work, without the depth peeling? Would it be okay there? And I don't think it would be. Well, no, I guess, to be honest, I guess I don't know exactly why those are having that problem either. Meaning along that boundary, I would expect we should be able to get multisampling along that boundary to work properly as well, unless the problem is that it's not the primitive's edge because it's a little too fat, so it sticks inside of it, and the primitive edge, so it doesn't turn on multisampling in that case. Because I don't know if it uses the Z testing to check. So I wonder if it's our centroid sampling that is that makes that be the problem, right? Because our centroid sampling forces all of that to be having the same value, and that prevents you from getting multisample there probably. So if I were to turn off the centroid stuff, I wonder if that would improve that situation. So if I just take centroid out of here, right? I guess I didn't need to do that. It's just that. Yeah, so it's really just the centroid that ruins that. But if you take a look at what we've got now, right, where we're just taking the maximum depth value, that's actually really nice and smooth, and it smooths those intersections. So really at that point, we're just talking about some of that when we sort of clip out, there's some objectionable sparklies in there. But everything else is pretty nice, right? And I mean, if you compare these two, especially here at this lower resolution, which admittedly is not exactly fair because, well, you wouldn't run into lower resolution, but, if you take a look at those two, It's really a lot nicer with multi-sampling on. You know what I'm saying? All right, so I'm just not willing to quite give up on this yet. So I guess what I would say is we're gonna have to pull centroid out. It's pretty clear that without centroid, you get way better anti-aliasing on those intersection points. So I'm just saying it's out. Centroid is gone. Goodbye, centroid. No more centroid. Oops. Because that looks way nicer to me, right? I am a fan. I am a fan of this. That looks really nice and smooth. And I don't get a lot of those sparklies. I hate those sparklies when things move and you get the sparklies. Right? So really we're just talking about those artifacts which we mostly can get rid of with an alpha test, which is what I turned on there. And I'd almost be willing to live with that, but there's a little bit, I wonder if we can just do a little bit better. Like you can see some of those artifacts right at the edges there, right? I'm not quite sure it's because the clipping. Right, you can see right in there, I don't know if you can see it. You can see it's just subtly wrong all the time right at those edges. Very close now. Very, very close now, though. So the question is just, could I do something in the multi-sample resolve that's a little bit better about how it processes those multi-samples? So we know that if we pick the max depth here, I guess I'm not 100% sure when we're doing that pick. I guess I'm not 100% sure again, and this is probably just the fact that I always have to work on it on a weekend and then there's a week in between and maybe my brain just kind of loses some of the context that's important in really thinking through a problem that you don't totally know what's going on, right? It's important to try and get to that understanding. Sometimes you need more focus than that provides. But if we take a look at what's going on there with picking the depth maximum value, which is the furthest away thing, then I guess what I'm not clear on is right at the edge when it does the multisampling. If the alpha value, I guess the problem is if the alpha value is very low, then for those samples, what you want to do is you want to pick up, okay, so I do know exactly what's going on, so that's good. So the problem is, if when you do your multi-samples, right, you end up in a circumstance where you've got 1, 2, 3, 4, 5, 6, 7, 8. So if you end up in this circumstance where you've got a bunch of samples and you're doing something like this, and so you've got all these samples here that you want to talk about, but their alpha value is very low. So when you pick all these guys up, you've got 5 samples, but the 5 samples all have alpha values of like 0.1, right? As a result, you're going to produce the combined. You're producing the combined color here using the multisampling. So you're going to get a 3 that have some other color here. But what you wanted to do was you wanted to figure out what the color was on the next depth peel down from just these samples, right? You wanted to figure out what the depth peel value was there and add that in. That's what you're trying to do. But you're not going to do that because these samples are already from here. So you're actually going to skip this depth altogether and get down to the next depth peel, right? And only this amount of contribution came from this layer, which is not what you wanted. So you get way more of this color than you should get in this peel, and that's incorrect, right? Or vice versa. And so when you pick the minimum color, what you do is you preserve the depth peeling, right? When you pick depth min, you preserve the depth peeling effect very nicely. What you don't do is you don't get drilled down deep enough, right? And especially when things are overlapping, you end up in a bit of a pickle there, right? Now, I don't know, like maybe there's simpler things that just happen to not produce as much of an error. Like, I don't know. Maybe if we did the, depth min equals 1 and, we took depth and we grabbed it here. And I just tracked both. And, we split the range in half. Right? Who knows? I'm making stuff up at this point. So, like if we take a look at what happens there, what do we get if we just split the depth range in half? So if it's going to be mostly what it would have been if they're close together. If they're not close together, it'll pick something, halfway in between, right? What does that look like? And, well, what I would say is I see a lot less artifacts of the kind that we were talking about before. And I guess I would be interested to know, just looking at it here, I'm not seeing those artifacts on the top of the trees, for example, right? And maybe, right, if I also took a look at how we were doing the threshold, maybe that, what happens if I back off that threshold again? What do the artifacts look like in this mode with no thresholding, right? And oddly enough, I don't see any. So it doesn't look like the alpha threshold actually needs to be there if you split the range. So right now, honestly, the only artifacts I'm seeing so far are mostly in peeling away. Like right now, in the peeling away, like you can see some flickeriness there, right? That's mostly all I'm seeing. I would like to know whether an alpha threshold makes a difference for that. I have no idea. Let's find out. Doesn't appear to. So I guess I would say at the moment, it's weird that such a simple solution happens to be so good, but that really does look pretty shippable. I don't love the pull-through of artifacts there. I don't love the artifacts that I'm seeing right here. But that's really it. In terms of just rendering the scene, that looks real stable and very nice to me. Everything is silky smooth there. I'm pretty happy with that so far. Any questions? Any questions? Any questions? Also, we did that yesterday. I don't know what other issues we've got outstanding here. Unused variable by mistake. So this is not a bug, that's just a suggestion. Two small compiler warnings in VS17. Peel index has previous effort. Oh, okay. First warning or second is the shadower. Fixing the last one involve changing set cursor. These are pretty free to change, and they would help if they would help people compile on VS17. That's fine with me. So that's in here. You see arrow. Resource. So that's just going to cast that to the proper value. Value for the compiler to be happy. Declaration of peel index hides previous local declaration. That's in here. Probably a for I loop. Yep. So I'm going to go ahead and change this one to onPeel index. Since it's a little more global and I'd like it to be a little clearer. I really wish, I need to figure out a way to make for coder not stop searching for things because you scroll. All right, I think that's it. All good. Yeah, uplink coder, I wish there was some way, and I guess conservative rasterization is the thing that, like I talked about at the beginning, is the thing that I want, and some modern cards now have added that. Looks like NVIDIA and Intel, both have that. Caleb, what about the typecast? What about what typecast? This was the typecast, right? Make int resource. Oh, hey, NREC. Yeah, game-wise, this isn't really much of a game stream. It's a programming stream. So the engine coding is the point of it, if that makes sense. And we're kind of coming to the end of that, so we are going to build the game on top of it as well, just to show how that part is done. But I'm not a game designer, so that part will be more just about like, hey, so here's how to code the game part of the game in case you didn't already know how to do that from all the stuff we've already sort of shown, because a lot of it's kind of pretty obvious, I think, at this point. If people have followed the whole stream, they pretty much know how to, make a game on top of it now, because the game code is not particularly complicated. So we will be doing that part, but it's not really the point of the stream, if that makes sense. The game coding will be much less important than the engine. So I guess that's what I would say. So it's not really much of a stream for people who want to make games, as the primary goal is just to make a game and don't care about engine work, because the point of the stream is the engine work, not the game. If that makes sense. There are plenty of, at least I think there are. I think there are other streams available that are more about making a game, and so they just boot up Unity, and show how to put entities in or something like that. And so I at least think there are streams that cover that kind of stuff, and this is very far from that, right? We even wrote our own software rasterizer for the game at one point, which is something you would never do for any real reason. It was just to sort of educationally show, here's how rasterization works, and here's how you should think about it. Here's what the GPU is doing under the hood, and let's implement that ourselves so we can understand it. That sort of stuff. So we pretty much are very heavily focused on learning to program engines and how they work, and we don't really focus on games or game design. And again, that's because I'm not a game designer, so I feel like that's really someone else's stream to make. I wish there were good ones of those. I don't know if there are. Good game designers are very hard to come by. There aren't very many of them in the world. There's a lot of game designers, but very few of them are good. And I don't think any of them that I know of stream. I I mean, that's not entirely true. Like, Jonathan Blow does streams, and he is a great game designer, but he doesn't do streams on game design. He streams like when he's programming his compiler or something like that, which is great, but not, you know, yeah. I guess what I'd say is it's not helping anyone whose main goal was to see how a great game designer does that work. John Blow streams aren't going to help you because he doesn't show that, right? He shows how he does programming on other things. Was enabled. As it appears you are nearing the end of the main engine dev, will you be adding in the non-Win32 layers too, or have others already done those? We won't do ports till the very end, so the game will be done on Win32, and then we'll do the ports. That said, yes, other people have already done them. If you pre-ordered the game, you can actually go on the GitHub, and people have ported it to SDL, which is a cross-platform like library thing. So I think if you care about that, you can go get one of those, and that would allow you to run it probably in most places to at least a certain degree, because SDL has code for lots of different platforms. However, I don't have any experience with that branch myself. I've never looked at it, so I don't know what it does or doesn't do. I will port the game to the other platforms eventually, at least probably Linux, Mac, and Raspberry Pi, because those are open platforms. Now, one of them may close by the end of that. Like, Mac may be a completely closed platform by that time. I mean, heck, Windows may be a closed platform by that time. I have no idea. Platforms are rapidly closing up. But Raspberry Pi will be open, so we'll definitely port to Raspberry Pi, right? But what else we port to, I don't know. And Linux, right? Because that's open. So Linux and Raspberry Pi, and those are both similar ports because presumably we could do a Linux Raspberry Pi port. Although it might be more fun to do a whole cloth Raspberry Pi port, but yeah. All right, looks like we're done with the Q colons. So I will go ahead and I will wrap it up for the day. I'm surprised at how well that multisampling suddenly started working. I guess once we fixed the bug. With the custom resolve, it turns out that just a small change to the custom resolve produces a very good result, which doesn't make a whole lot of sense to me why splitting the depth range in half is suddenly somehow magically amazing, but I guess that's just like you're bisecting the difference between the two. I don't know. It's a bit odd, if we're honest. If we're being honest about it, it's a bit weird. But yeah, I mean, just looking at it now, I feel like most of the bugs are just in that movement downwards. But in terms of rendering the scene, it's like rock solid. I don't see any problems that I notice rendering the scene. It looks great. I mean, for not doing any sprite sorting at all, just dumping all the sprites into the engine and having it completely resolve it with depth peels plus multisample, that's just kind of crazy. I'm like pretty impressed by how well that works. Before we started, I don't think I would have said that I mean, I had really no idea. Like, I'd never thought about using depth peeling for a 2D engine before. I'm kind of surprised at how well that works. Well, sometimes you get lucky, I guess. I don't know what that is. Notifications. I love when your developer studio has notifications. All right. Thank you everyone for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. If you would like to follow along with the series, you can always pre-order the game on handmadehero.org, and it comes with a source code so you can play around with it and practice the stuff that we have talked about on the stream. Or in the case of MTS Mocks, find bugs for us that were really helpful. We may never have revisited that if he hadn't taken a look at it, or she. I don't actually know MTS Mocks personally. Although I often see them on the stream. I remember the MTS Mocks nickname coming up. So thank you very much for finding that. That was great. And it made us go back to it and actually do something pretty cool. So I think that's a pretty valuable thing. That's about it. Until next time, if you have questions, you can go to the forums, talk to other community folks about it. You can go to the Patreon page. If you want to support the video series, you can check our schedule bot to find out what the schedule is going to be. And you can go to our episode guide to catch up on old episodes if there's something that you missed. That's about it for today. Until next week, yeah, have fun programming, and I'll see everyone on the internet. Take it easy, everybody.